Okay, this new section, which is section 4, brings us into studying more of the electrons and how ions are formed. So we're going to start this out by a great lab activity where we complete flame tests. Flame tests are very interactive. You get to see a bunch of different things, but there are some safety concerns that we do have to pay attention to when we do the lab activities for this, okay? So this lecture that you're going to have here really is just kind of priming the pump, and we're going to talk about some things with the lab. We will do that pre-lab in class when you come in tomorrow. But after you do the lab, you are going to watch the actual lecture itself, okay? And so that will be kind of a homework assignment for you, okay? So something to understand, flame tests provide evidence for the presence of certain amounts of atoms in compounds. Different metal atoms produce different colored flames when they're heated. Flame tests give us evidence that atoms are not destroyed. Remember, law of conservation of mass, law of conservation of matter. They're not destroyed when they combine to form compounds, okay? So the learning goals here that I have for you, you're going to be able to conduct flame tests and use the results to determine the identity of the compounds, and you're going to be able to interpret evidence of the presence of certain atoms within compounds, okay? Big idea here is the presence of certain atoms, and we will learn, you know, what are those certain atoms, or what do these different substances have in common during these flame tests, okay? So the one vocabulary term here is a flame test. So it's a test used in a lab to look for the presence of certain metal atoms. So we take a sample of a compound, we heat in a flame, and we make observations. We don't have to do any calculations. We're just making observations, and we do those with our eyes here, okay? We mark down whatever color is produced. So you'll see here in this picture a student. He has a metal wire or a metal loop, and he has the bottom of it sticking in the flame. And you'll notice that we don't have our normal orangish flame that's being produced. You see kind of a bright green color. So we will learn what caused that green color to be visible, okay? So let's prime the pump here. These drawings are models that show solid copper chloride, and aqueous copper chloride as collections of atoms, okay? So we see these as solid copper chloride, and aqueous copper chloride as collections of atoms, okay? So let's describe each of these models. So there's a key there. If we look on the very left-hand side, we see solid copper. Well, how do we know that that image on the left-hand side is solid copper? Well, we know solid copper isn't a compound. It's just an element. So we just have atoms of copper in our sample. Those are packed really nicely and tightly together, okay? In the middle there, we see solid copper chloride, okay? Again, it's a solid, so those particles are packed really closely together. There's no space in between them, but you see a series of chlorine and then a series of copper, okay? And you see those bonded together. On the very right-hand side, you see aqueous copper chloride, okay? Aqueous copper chloride, which is CuCl2, you will notice you're going to use that key even more. You will see water molecules mixed amongst the coppers and the chlorines. Okay, well, how can we think, you know, what is similar about each model and what is different? Okay, each model contains copper. Okay, take a look. Each model contains copper. And we can tell that by looking at the key. Hey, what is that darkly shaded sphere? Okay, the first two models that we have, they're both solids. We know that because they're packed tightly together. The third one, we know it's aqueous because it has been dissolved in water. We can tell that because we have those water molecules there, okay? The first image is just one single element. The other two are considered compounds. They're considered compounds because they contain more than one type of element, okay? So what you're going to do, you are going to complete the lab activity but first we will do a pre-lab together. We'll, go back over lighting Bunsen burners, We will look at our lab sheet itself, and we'll talk about how we are collecting data, okay? After we do the pre-lab, then you'll be able to go around the classroom and gather lab data. This is an individual lab, so you won't have to work with a partner, but there'll be multiple stations set up, so there's enough room for everyone to be able to access some Bunsen burners. If there's a chance that you feel, hey, you know what, my data's looking a little weird, some colors I'm not seeing as much, some colors I'm seeing more than others, you're always welcome to go back and reflame or retest different samples. Just make sure you are marking your data down in the correct space.